Welcome to the product demonstration of frequency locked loop DC motor speed control. In this project we are going to control this DC motor speed by the frequency controlling of this PIC 16F72 microcontroller. Here we are controlling this speed of the motor by using the pod, which is variable resistance, and by changing the pod readings we can change the frequency, means pulse readings of the DC motor, and this pulse reading is given by this microcontroller. Here we are taking this input of the variable resistance, and we are generating the frequency by using this crystal oscillator, which is PIC 20 megahertz crystal oscillator used to generate clock pulses. This microcontroller will take the input of this pod and will generate the clock pulses according to the input of the pod resistance, and this will be displayed on this LCD display, and the readings pulses frequency is given to the BC547 transistor, which is here the circuit is used as a switching circuit, means here we are giving three connections. One is base, collector, emitter. Whenever we are giving the base pulse, up to then the motor will be rotated, and here we are controlling the base pulse, means we are giving the clock pulse low, we are controlling the clock pulse and decreasing and increasing the clock pulse. By that we are going to control the speed of this DC motor, and whenever giving the clock pulse, then supply will be controlled. Like that the motor speed will be controlled, and this here we are using IR sensor, which is used to measure the speed of the DC motor. And here we are having two lights. One is transmitting light, and also one is receiving light, which is photodiode. Here the light will be transmitted from this IR rays, means infrared rays will be transmitted from this light, and whenever any obstacle came before it, it will be received by this, that will be reflected and received by this photodiode, and that will be taken as an input for this microcontroller. Like that we are going to measure the position, means how many times one circuit one rotation is complete. If one rotation is completed, it will touch one time. Like that we are measuring the RPM of this motor, and that will be displayed in this LCD display. And whenever we are changing the frequency also, that frequency means frequency lock also will be displayed, and whenever we are changed to the frequency up to some RPM, and at that RPM, near that RPM, the motor speed will be locked. Like that we are going to control the speed of this DC motor. Let us see the demonstration now. Now I am using this adapter, which will convert the 230 volts to 5 volts, and that is the input for the input supply for the DC motor and microcontroller and pod, and this switching circuit and IR sensor and LCD. It will be parallel dispersed by using this PCB, which is printed circuit board of the microcontroller. By giving this supply, we are having two LEDs. One is a power indication LED, and another one is pulse indication LED. And we can observe here the pulses are going to the DC motor. Then the motor is rotating, and now the frequency set up to 122 RPS. And we are measuring RPS of rotation per second, and here the set speed 122 RPS, and the speed of the motor is 120 RPS. Rotation per minute, rotation per second is 120 now. And now I am just changing the frequency now by rotating this pod, and we can observe here the readings are changing. And whenever I am changing this speed, means the resistance of this pod, automatically the readings will be changed, and when we are lowering it, it is changing to low. Means we are by increasing the resistance, we are increasing the frequency. By decreasing the resistance, we are by increasing the resistance, we are decreasing the frequency. By decreasing the resistance, we are increasing the frequency or clock pulse generation. And here we can see the RPS 15 seconds and the motor is stopped. And again I am increasing, like that it is slowly will increase the speed. Like that the pulses will be given to this circuit, which is BC547 circuit, and by the input of the circuit the supply will be given to the DC motor. And now I am again decreasing the speed, and we can see here RPS is 5, 6 and 10. Then also it was not moving. And here we can observe after one set of speed it will start rotating. Yes, exactly 48, 47 RPS. Then the speed will be pulses will be started supplying to the DC motor. And here we can observe the set speed and the speed of the motor is maximum same. It will be adjusted directly according to the input frequency. Like that we can control the speed of the DC motor by the frequency lock system. Okay, and it's about project. Thank you.